This video is all about network hardware. So we need to be thinking about what kind of hardware do we need to form a network. So the different hardware devices that we're going to look at, we've got wireless access points, which you are probably familiar with anyway, routers, switches, what we call a network interface card, also might be known as a controller, transmission media, so that includes different types of wireless and wired connections. And then we'll look at a complete example of a network, and you'll be able to see how all these different components actually fit together. So let's start off by looking at wireless access points. Okay, are you ready? Right, let's go. So we need to be able to describe the task performed by a wireless access point, know how a wireless access point connects the computer to a local area network, and although this is not strictly on the course, I think it's useful to be able to know what is meant by a hotspot. It's one of those key technical terms that you should be aware of. So hopefully by now you're aware that computer hardware is any kind of physical device. So if you drop it, it's either going to break or bounce, right? We're talking about a physical device. So a wireless access point, you've probably got something that looks a little bit like this at home, or you've seen these around schools. And a lot of this you're probably already familiar with. So what does it do? Well, it just enables us to connect devices to a network via wireless means or by Wi-Fi. Yeah. So how do we actually connect? Again, you've probably done this hundreds of times already, haven't you? So on your phone you might have searched for a Wi-Fi connection, or on your computer you've searched for Wi-Fi networks, and you see a whole list of networks. How do you know which is which? Well, they've all got what's called an SSID. That's a service set identifier. Might be worth learning what that term actually means if you don't already know. So a list of networks come up. They've all got names so we can identify them. And you can probably notice on here it tells us the signal strength as well. There's a little icon that appears slightly differently depending on the strength of the signal, i.e. how close we are to that particular network. Now, of course, wireless access points are usually set up to use some form of encryption, because anyone within the vicinity of a network could theoretically capture that radio signal that's whizzing around the air. They could capture that, and from that they could look at all the data that's going between different devices. So what do? We encrypt the data. Okay, it doesn't stop people from accessing the data, but it stops them from being able to understand what that data means. So usually also when we connect to a wireless access point, we have to enter a password. So that can be set up so that it restricts who can actually use the network. Now, as for the wireless device itself, you can just about make out on this image there's a yellow and blue cable here. I think it's the blue one that's connected to the access point. So that access point connects to the network itself via a cable. Not everything is completely wireless necessarily. So we can connect to that Wi-Fi access point wirelessly, but then that cable will probably connect to something called a switch, which we'll look at very, very shortly. So a hotspot, that term essentially means the range in which we can access that the Wi-Fi access point, the wireless access points. So if we are sitting miles and miles and miles away from the wireless access point, well, we're not going to be within the hotspot of that point. So sometimes in some buildings we might need to have multiple Wi-Fi wireless access points in order to be able to connect everyone and to have a big enough hotspot. So hopefully you can describe the task performed by a wireless access point, which is simply to connect devices wirelessly to a network. You'll know how a wireless access point connects the computer to a local area network, i.e. we search for the networks, we select it by SSID, we type in our password, and then fingers crossed it all works, and you're aware of what the word hotspot means. Let's take a look at routers. Now, sometimes people confuse the word router and switch, and they both perform a slightly different task. What's confusing is that routers can actually behave as switches, and some switches have a built-in router function. But we're just talking about them discretely right now. So we need to be able to describe the task performed by a router. Now looking at this image, it pretty much gives away what the task is, because there's a socket here that says internet. So what a router enables us to do is to connect one network to another. It's not necessarily connecting to the internet. I mean, yes, you do need a router if you want to connect to the internet, but fundamentally the purpose of a router, i.e. the task it carries out, is to connect one network to another. This second image here of a router shows a WLAN light, and so wireless, that stands for wireless LAN, and a number of other LAN lights, because what this device is doing is connecting different LANs together. So I put here in these notes, repeat aloud, routers are used to connect one network to another network. So it's not necessarily to connect to the internet, but yes, we will need one to connect to the internet, but it's to connect one network to another. So describing the task in a little bit more detail, well, what does it do? So when it receives data via one port socket, so there's a cable that plugs into it, it will look at the data that's sent and then figure out which port that data then needs forwarding to. So it receives data from one port, takes a look at that data, and then works out exactly where that data needs to be routed. And that is fundamentally what a router does. Now, of course, routers are run by an embedded system, right? It's got its own processor and its own special purpose operating system that carries out its function. So hopefully you get the idea of what a router does. It connects one network to another. That's the main point. So what about a switch? So you're probably looking at this picture, if you can see it, of a switch, and from the outside it looks pretty much the same as a router. And indeed this switch might even have a router function on it, I don't know. But what is it? What does it do? What's the task? So a switch is, again, it's an item of network hardware, but it connects computers together that are on the same network. So if you think about all of the computers in a classroom, right? Each one of those computers has a wire coming out the back of it, and then that wire will go into a switch. So what does a switch do? So like a router, it looks at the data when it's received, and then it figures out which ports to send it out on. So it receives it via one port, looks at the data, and then figures out where to send it. And it does this predominantly, that's a long word, based on what we call a MAC address. So every device that connects to the switch will have a unique, what we call MAC address. And it's a bit like when you're posting a letter. All right, it uses that address to figure out where the data has got to go. And switches can be pretty big. They can be pretty big. They can have lots of cables connected to them. So that's a switch. What about a NIC, a network interface controller? So this is the device that might be inside your computer or laptop or Chromebook. There's probably a network socket on there, which would enable you to connect a cable to your device and then plug that cable into a switch. So this network interface card is needed so that your device itself can talk to the network. So most modern devices will have one of these built in. There won't be a big massive network card as shown in this picture. There would be a socket, but then those connections on there would connect directly to the motherboard, which would contain the necessary electronics to handle network connections. So it wouldn't necessarily be a separate plug-in card as what's shown in this image. And yes, of course, they can be wired, but they can also be wireless. So there might not be a socket at all. It just connects to a little antenna that's inside your computer and transmits a wireless signal instead. So, so a wireless or wired network interface card allows your device to connect to a network. And it can be wired or wireless, and each one of these devices has what's called a MAC address, which uniquely identifies it. It's just a 48-bit number that's usually expressed in hexadecimal. So you might be asking, well, what about my Wi-Fi router at home? What exactly is that? Well, actually, it's an all-in-one type device. So if you've got the internet at home, you might have a box that looks something like this. So it's a wireless access point. There's also a switch that's in there that enables you to connect several computers. There's a router in there, so your network can be connected to the internet, and also what's called a modem, which you don't need to know for this course, but a modem translates signals from analog to digital, or digital to analog, and vice versa. It does both. So modem literally stands for modulator demodulator. So if your network signal needs to go over a phone line, it will use a modem to pretty much translate the signal to another type of signal which can actually be transmitted over the phone line. So transmission media, examples of transmission media, we're just talking about different types of cable, and we look at this in more detail in the next unit anyway. But you're probably already aware in a network we can have fibre optic cables which are made out of glass or plastic, which are super fast because it uses light to transmit the data. Or Ethernet cables, again, you've probably seen these around school coming out of the back of the computer. So they are used to connect devices within a network. One more term here that you really need to be aware of is bandwidth, which means how many bits per second we can transmit across a network. So the more bandwidth there is, the more data we can transfer in a second. So again, we cover that elsewhere in the course. So let's bring this all together and look at an example of a network, right? An example of a network. So this could be from a school. So where should we start? Let's start with the router down here. So this router connects the whole entire network here to the internet. So the role of the router here is to connect one network to another. And in this particular scenario, we're using a fibre optic cable to do that. This router connects to a switch, and this apparently is a fast switch. There's different types of switches depending on the speed that they're rated at. So this switch here connects to some different servers. It also connects to a Wi-Fi wireless access point that enables devices to connect wirelessly. And it also connects to another switch, so switches can actually indeed be connected together. So this switch might be for one particular classroom, and you might have another switch which is for another classroom in school. And each of those devices in the classroom are connected to the switch. And you can also connect a network printer directly to a switch. Now this device here is a hub. Hubs are not really used anymore because they're really inefficient and we don't actually need to know about them for the course. But you know, I said about how switches, when they receive data, they figure out where it needs to go and forwards it to the corresponding ports. When a hub receives data, it just repeats it and sends it to everyone, which of course is not particularly efficient, and it's a nightmare for security because technically someone else could intercept data. So hubs are really cheap and nasty, and we don't really use them anymore. We use switches instead. So we've looked at wireless access points, routers, switches, transmission media, and a network example to bring it all together. But the key points: a router, the job of the router is to connect one network to another, and it does that by, when it receives data, it looks at what's called an IP address within the data and then figures out where to send the data, which port to forward it to. A switch is very similar, but it forwards data based upon a MAC address. So a switch is used within a network, but a router is used to connect one network to another. It's probably worth taking a copy of this diagram and using that to memorize the purpose of these different network devices.